This lesson is to go over angle pairs. This lesson will teach me to define special angle pairs and understand the relationships between them. Define and draw a diagram for each definition. Adjacent angles says it's two coplanar angles that have a common side, a common vertex, and no common interior points. So when we talk about coplanar, it just means they're on the same plane. They're on the same piece of paper. So we have two angles. Here's one angle, and here's the other. And if you notice, they're sharing this side up the middle and this common vertex. I'm going to try to use the same lettering combination so it saves us a little bit of time. So in regards to notation, we can say that angle ABC and angle CBD are adjacent. So again, what it means to be adjacent is that they have this common side that they share and this common point. One thing to know about adjacent angles is that it describes a location and not a relationship. The analogy that I give in class is thinking about your locker. Your locker is adjacent to another locker, but that doesn't mean that you have a relationship with the person in the locker next to you. It just means that by location you're next to each other. Complementary angles are angles that sum to 90 degrees, and sum is being added. Excuse me. So we have two angles. Oops, let me start over here. Two angles. So here's one angle, and here's my second angle. Two angles are complementary when they add up to 90 degrees. So these two angles happen to be adjacent and complementary using the same labeling ABC and then the D out here. I can say that angle ABC and angle CBD are complementary. The other thing we can do is when we talk about these angles being complementary, we're talking about the physical angle. So what we could do in regards to the measurement is say that the measurement of angle ABC added to the measurement of angle CBD, they add up to equal 90 degrees. One thing that I do want to let you know is that complementary angles don't have to be adjacent. So again, these two angles that I have drawn are adjacent, but if I were to separate them, they still will add up to 90 degrees. They just don't have to be side by side. Complementary is very similar to supplementary. Whoa, stop scrolling. The only difference, stop scrolling for real. Haha. The only difference is that these add up to 180 degrees as opposed to 90. So if I had an angle here, and here's another angle, these angles are going to add up to 180 degrees. So there's 180 degrees here in this straight line. Using the same labels, I'm hoping that it makes all this a little faster. I can say that angle ABC and angle CBD are supplementary. Similarly to how we did it in complementary, I can say that the measure of angle ABC added to the measure of angle CBD is going to equal 180 degrees. And just like complementary, supplementary angles also don't have to be adjacent. Close enough. So the idea here is that these two angles can still be separated. They still add up to 180 degrees. They just don't have to be touching. A linear pair is a special case of supplementary angles. In a linear pair, these are things that are both adjacent and supplementary. So the diagram is going to look identical. They have to be adjacent, meaning these will not be separated. Supplementary can, linear pair cannot. So I have all the same labels, and what's different here is that instead of just calling them supplementary, I'm going to be even more specific and say that angle ABC and angle CBD are a linear pair, or even better yet, let's say that they form a linear pair. So yeah, these aren't going to be pulled apart. Vertical angles. Vertical angles are formed when two opposite lines, they're angles that are opposite each other. Probably should have put the word each other. When two lines cross. So here's a line, here's a line. Vertical angles are formed when they cross. So I have one pair of opposite angles or vertical angles here and here. And I have another pair up here and down here. So let me get that marker back so that we can label them. If I were to call this A, B, C, and a D, E, the green ones are angle C, B, D, and I'm having a hard time writing some of those letters, and angle ABE are vertical angles. And then the other ones are the red ones, angle ABC and angle DBE are also vertical angles. And I'm abbreviating vert because I'm having a hard time writing on my tablet. Excuse me. The linear pair postulate. Just a refresher, a postulate is something that has to be accepted as fact. You can't question it. Conversely, a theorem is something that can be proven. So when we talk about the linear pair postulate, it says that if two angles form a linear pair, then they are supplementary. So the idea of a linear pair is that you have two angles on here that form a line. And what I ask my students is, well, how many degrees is a straight angle? And they always tell me 180 degrees. And then I ask them why, and they say, well, it just is. Straight lines are 180 degrees. And it's this idea that a postulate, that it's something you just know to be true. So all I'm going to do is to take this notation and I'm just going to clear it up to say that the measure of angle ABC added to the measure of angle CBD equals 180, and that should be a plus. So it's basically that diagram drawn down here, A, B, C, D. So the linear pair postulate says that if two angles form a linear pair, yes, this angle and this angle do indeed form a line, then they have to be supplementary, meaning they have to end up equaling 180. And similar for the vertical angles theorem, this says that if angles are vertical, then the angles are congruent. So if you notice up here, we listed that these angles are vertical, and then we listed that these angles are vertical. So what that means then is that angle CBD is congruent to angle ABE, and I'm using all of this information. So if angles are vertical, which we identified the green angles to be vertical, they have to be congruent, and that's because of this vertical angles theorem. And then the green is angle ABC, has to also be congruent to angle DBE. All right, moving on. Whew. Okay, it says name the angle pair shown and find the measure of the indicated angle. So when we went through these in class, most students were able to look at this and say that the measure of angle 1 is 60 degrees. I asked them how, or I asked them why, and they say it's because lines form 180 degrees. So the pair that's being used here, or this special angle, is that it's a linear pair. For the measure of angle 2 is going to equal 95 because these angles are vertical angles, and we know that vertical angles are congruent because of that vertical angles theorem. So this angle is the same as that angle. If you look at the next one, this means it's 90 degrees. So there's a 90 degrees over here. So the measure of angle 3 is going to end up equaling 70. and we know that because those two angles are complementary. For D&E, I'm straight up telling you that these angles are supplementary, and I'm doing that because they're non-adjacent, so they're not going to form a line. But regardless, I'm telling you ahead of time these are supplementary, meaning they equal 180. So the measure of angle 4 is going to equal 125, so that they add up to 180. Letter E, I'm telling you they're complementary, meaning they have to add up to 90. So the measure of angle 5 is going to equal 55, so that the two added together make 90. The next two aren't definitions from today, but in letter F it says the measure of angle ACB. This whole angle is 25 degrees, so that means the measure of angle 6 must be 10. And when I ask students how they know that, they usually tell me that they subtracted. But think about what's really happening. You're taking, you're taking a part plus a part, and you're getting a whole. So the concept that is really at play here is the angle addition postulate. Letter G. You notice we have these curves, so that means that the measure of angle 7 has to be 60. And when I ask students why, they say, well, because the curves are there. Well, why are the curves there? Because those two angles are congruent. But what I'm asking is what concept, what's at play here, allowing those two angles to be congruent? And the answer would be that there's an angle bisector. Those two angles are congruent because this must be cutting the entire angle in half. Looking at letter H, it says which angle is vertical to CJE. We'll trace CJE. And the definition of vertical is that it's formed by intersecting lines. So take this part and extend it, take that part and extend it, and you'll see that angle AJG is forming the other part. Looking at letter I, there's going to be two steps here, and different students see different things. We need to find the measure of angle 9. What I see is I see vertical angles because they're formed by these two lines here. So meaning the 95 can move up here because I know that vertical angles are congruent. Then what I notice is that the 60-degree angle, that 95-degree angle, and that number 9 all make a straight line, and I know that lines add up to 180 degrees, that the angles on the line, so this angle and this angle and this angle have to equal 180, so that 180 minus 60 minus 95, minus 180 minus 60 minus 95 is going to give me that 25 degrees. I'm going to pause the video. I'm going to fill in the rest of it so that I can get it done in the 2 minutes of the video that I have. So hang tight. All right, here's the last little bit. I've got about a minute left. So in this problem, they gave you the measure of angle 5 was 26 degrees. I don't think you need to go numerically, but what stood out to me is that if this was 26, then 3 must also be 26 because they're vertical angles. From here, I saw that, well, if that's 26, this is 90 degrees. So that means angle 2 must be 64 because 2 and 3 are complementary. I notice here that if 2 and 3 are a 90-degree angle, 1 is on the same line as it, so 1 has to also be 90 degrees. And lastly, for angle 4, seeing this line here as well, the 26 degrees and this angle 4 formed a linear pair, so that must be 154. So notice the math language that I'm using. We're using words like linear pair, complementary, vertical, all of those things. So there's the lesson. Please let me know if you have any questions.